So this brings us to practical number 3 on electricity. If you are lucky, one of these questions will come out for you. Now, for electricity, these were the apparatus we were told to obtain. We have micrometer, screw gauge, we have the rheostat, we have a cell of 1.5 volts, we have a voltmeter from 0 to 2 volts, and then we have our ammeter from 0 to 100 milliampere. We have 1 meter long Constantan wire SWG28 or 1 meter long Constantan wire SWG labeled B, one standard resistor labeled RX, and it is 2 ohms. Is that clear? Now you have your connecting wire and your keys. Now you should observe something. Your voltmeter is always connected in parallel. Is that clear? And you respect the polarity, the colors you are seeing, red and black. You are seeing plus and minus. This plus always goes to red. Then the ammeter is always connected in series because it records and reads current. Then the rheostat here is to introduce resistance in the circuit. Is that clear? Please take note of this. Alright. Then let's proceed to how your question will look like. This is how your question will look like. Either this one, okay, I'm very sure about this. After either this particular one, you can see the connection, your cell 1.5 volts, okay, because from the question, from the white paper, we are told to obtain 1.5. So this is 1.5 volts. This is your switch, and then this is your ammeter. I told you you are going to connect it in series. You can see it is connected in series. Then we have a voltmeter. You can see it is connected in parallel against your 2 ohm resistor. Can you see it? That's why I said this practical might be the one. If you are very serious about this, you don't need to waste your time. Is that clear? You can see our 2 ohm resistor, you can see our voltmeter, our ammeter, our key, our cell, then our rheostat. Can you see how the connection is? So you are going to use this to be touching this. So it means you are going to be adjusting the rheostat to obtain the values of either the current or the voltage you are told to obtain. If it is not this one, it might be this. Observe the two. Okay, you see this one. This is your ammeter, also in series, but here we don't have voltmeter. Okay, but we have our Constantan wire because we are told to get 2 Constantan wire, so likely this can come out. All right, then you have a crocodile clip that you are going to use in adjusting the length of this in order to get your value of current that will be given from the questions. Now this is how your question will look like. If you're able to obtain this for this particular diagram, you are provided with a Constantan wire, a 2 ohm resistor, an accumulator E of 1.5 volt, an ammeter A key, and other necessary apparatus. Measure and record the EMF of the accumulator provided. Connect a circuit as shown in the diagram. You are meant to repeat this circuit. So make sure you do that by arranging your apparatus, whatever is given to you, arrange them first, then connect two wires to them first, two wires, one terminal, another terminal, then you begin to connect as you are seeing. You can see everything here is in series. It's only this part that becomes parallel connection. So take note of that. Then close the key, read and record the reading current at the original level when the crocodile clip is not in contact with the Constantan wire. So your crocodile clip is meant to be in contact with this Constantan wire. So when it is not touching this wire, record your current. Is that clear? Then with the clip making contact with the wire, when the distance equals 90 centimeters, of course you are going to have your meter rule to make sure you know the length here. Then close the key and record the ammeter reading I from the meter. So it means you are going to be using this D, this distance. Okay, this distance will be changing. Then your current will also be changing. That's what it means, because as you are changing the resistance value, the current flow will also be changing. If the resistance value increases, your current will decrease. If the resistance value decreases, your current will increase. They are inversely proportional to each order. Please take note of this particular part. Then, if you're able to achieve that, we know that we're going to evaluate D inverse, this D distance, evaluate D inverse. Repeat the procedure for 4 other values of D equals 80, 70, 60, and 50. So you are meant to do this 5 times. Okay, it might be 90 to this, it might be 70 downward, it might be 50 downward. So take note of this. This can change. In each case, read and record the ammeter reading and evaluate the inverse. Tabulate your reading. You are expected to plot a graph with I current on the vertical axis and D inverse on the horizontal axis. Determine the slope S of the graph and its intercept C on the vertical axis. Evaluate K equals C over S. Is that clear? Then using your graph, determine the current I when D equals 55 centimeters. State 2 precautions taken to obtain accurate result. Then you can have some questions attached, like explain what is meant by the potential difference between 2 points in an electric circuit. State 2 factors on which the resistance of wire depends. Alright? Under electricity, your setup might look like this. You're provided with 1.5 volt PD, which is your battery source. Alright, then you have your ammeter, your constant resistor, okay, then your voltmeter that are going to connect across, and then you have your potentiometer, which you are going to be using to vary the resistance in the circuit. Is that clear? So it will not go beyond this for one of the practical. So if you're able to achieve this, your table of value will look like this. You are only capturing 3 things: your distance, your current reading, and then your inverse of distance. So your I naught, when you record it, please put it here. We're having 0.95 depending on whatever you're having. Exactly, because the battery value also determines the current values, which is your voltage value, your PD. So you are going to have this. Observe, we're having 1 decimal places here, 1 decimal places here, 3 decimal places here. Please make sure you follow this if you want to obtain the maximum mark. The graph is shown as I'm going to show you below. The values of these inverse are expressed in standard form on the horizontal axis for easy plotting. If you want easy plotting of this, then you express this in standard form so that it will help you in getting your values. With this, you know that 10 raised to power minus 3 will become constant. Then you are going to be having 11, 13, 15, 17, and so on. It makes your work easier for you. The line graph is a line of best fit. Okay, so let's look at our graph. This is how our graph is going to look like. All right, so if you observe this particular graph, you see that this is our current, okay, against what? Our distance inverse. Please capture it very well. Then if you're able to achieve this, you see that this is our line of best fit. If you're able to capture 3, 4, 5, 2, that's good. Whatever you want to do, make sure your line of best fit capture the highest number of points that falls on the line. Is that clear? Then you can also obtain your slope. You can see, pick the outer one that falls on the line of best fit to the inner one. So this slope, if you are drawing this for WAEC, please draw this, pick this, and pick this. Is that clear? This gives you your slope. So you pit this against this, and then you pit this against this. You obtain your change in I against change in the inverse. Is that clear? So if you're able to achieve that, then you have the slope S equals I2 minus I1 over D inverse 2 minus D inverse 1. And if you do that properly, your slope will give you to 55.7 ampere centimeters. Why? Because already you are having divided by. So this will cancel out this. That's why you're having ACM as your SI unit. Take note of this. Then your intercept on the vertical axis is 0.975. Let's look at it. This is your intercept, where this your line of best fit intercepts your vertical axis, crosses your vertical axis, and say 0.975. something 95, right? 0. What? 9 0.975. If you observe, 0.975 is close to your original value of current. Can you see it? So this uh, slope intercept C should give you the value of, at least by approximation, the value of your original current as recorded. Is that clear? So your K equals C over S. And what is our C? C is 0.975 against what? Against uh, our slope 55.7. Now if you do that, our K is 0.0175 cm. So just know how to obtain this. It will make your work easier to do. Then from the graph, the corresponding value of I equals 2 ampere by approximation will give you what? You now check and you see what is given to you. That is question this. When D equals 55 centimeters, it will give you approximately this value. Then precautions, I ensure that the connections were tight. I ensure that the key is open when not taking readings. I ensure that the crocodile clip has a firm grip on the concertina wire. The potential difference between 2 points in an electric circuit is the work done in moving a unit charge from one point to another. Then the factors on which the resistance of wire depends, we have the length, we have the cross-sectional area, we have the nature of material, and then we have temperature. And it comes from resistivity. Okay, resistivity. If you know the formula for resistivity, it answers this particular question. Exactly, because it's RA over L. So if you're able to understand that, you answer any question that will come under this particular one. I hope this was helpful to you. So these are the practicals I expect that will come out in your exams. So it's either it is this or it comes in this format. As simple as that. If you have questions, you can drop them in the comments, and then I will see you in the next one.